Okay, here we go for the next two examples. Um, I hope that first part made sense. So what I'm going to do here, I'll post these videos. You can watch them a couple times if you need to for your further understanding. And then just doing the homework too is going to be very important for this unit. Okay, just understanding what, like the idea that average rate of change is the rate of change or the slope between 2 points on a non-linear graph, because non-linear graphs have the slope or rate of change is always changing. Okay, so that's kind of what we look at here. Is when we look at average rate of change, it's focused on non-linear graphs and finding the slope between 2 points. Okay, this question says the amount of money in a bank account for 1 year is graphed. Calculate the average rate of change between the following months. So it says, okay, find the average rate of change between 0 to 5. Well, okay, that's pretty straightforward. I'm going to say my run. So it looks like this point here is, let's say, 0, 500. And this point here appears to be 5 and 1,000. Okay, so I'm just going to go my A rock is equal to 1,000 minus 500 over 5 minus 0, which is equal to 500, divided by 5, which is equal to 100. Okay, so 100, and this would be dollars per month. Okay, that's our average rate of change there. The next one says between 5 to 8. Well, I mean, we can look at that one. I'll do it, right? But we can look at that one. It appears to be a flat line, and we know that the slope of a flat line is 0. Okay, this should be, common knowledge from grade 9. Okay, so we have here, if I want to do the same thing here, A rock is equal to, this one's going to be 1,000 minus 1,000 over 8. Oh, that's a bad 8. 8 minus 5, which is equal to 0 over 3, which is just equal to $0 per month. So this person had between, maybe those are, what's the 5th month? January, February, March, April, May. So June, July, and August, which makes sense, right? Those are the summer months. This person was not saving as much. Okay, they were kind of breaking even, and then it appears that for the last few months of the year, that this person's bank account took a hit. So probably during those months, maybe Christmas time, maybe there's a lot of birthdays, so they weren't saving much; they were spending. So this is 12 here, and it looks like 200. So again, all we're going to do here, and I'm going to label this one specifically. This is going to be my y2, x2, x1, y1. Just so you see here that the importance of the order of these points. Okay, but my A rock here is going to be 200 minus 1,000 over 12 minus 8, which is equal to negative 800 over 4, which is equal to negative $200 per month. So they were spending or losing $200 per month. Okay. So you can find, right, this is kind of a, this is a nonlinear function. We might call this, if you remember from our very first unit, this might be referred to as a piecewise function. All right, so you can determine average rates of change of a piecewise function. What do the positive and negative rates mean in the situation? Well, positive means they are saving money. and negative means they are spending or losing money. Okay, beautiful. All right, now our last example here looks at and I'm just going to take a scroll down here, but example 3 says a football is kicked into the air such that the height in meters after t seconds can be modeled by the function. Ooh, look at this. This looks fun. H of t, so height, with respect to time, is equal to negative 4.9 t squared plus 29.4 t plus 2. So that is a function, okay? That is a parabola. We notice that it's a quadratic. T squared represents a quadratic, tells us that this is a quadratic equation or a parabola, okay? Now, I'm just going to sketch. I'm just going to give a little sketch of what this graph might look like. Okay, we see that the a value is negative, which means that this graph opens down. We also, if I sub in 0 for t, our first value is 0, our second value is 0. So the height when time is 0 is 2. So this has a y-intercept of 2. And now what this graph is going to look like is this is a parabola that's going to go up into the air and come back down. Okay, the ball is kicked into the air, travels in the shape of a parabola, and comes back down to the ground. Okay, its height is in the shape of a parabola. So what it wants us to do here is it wants us to find the slope or the average rate of change in height during each of the following intervals. So the first interval it wants us to look at is between t equal to 0 and 1. So maybe that's between here and here. So basically what we're doing is we're drawing what's called the secant line between those 2 points, and we're finding the slope of that secant line. Okay? Now, the formula that we're going to use here, and I'm going to do this, I'm going to show you how I'm going to do this. What I want to do first is I need to figure out what these coordinates are, right? So I want to figure out, well, my first point is I know t is 0, and I want to figure out what the y value is there. And the second point, I know that my t or my x value is 1, and I want to figure out what my y coordinate is there. Okay, so in order to figure out what and we'll call this, let's write this in here. This is my x1, this is my y1, this is my x2, this is my y2. In order for me to find or determine y1, what I'm going to do is I'm going to sub in, I'm going to zoom in here, I'm going to sub in f of x1 into my formula. Okay, and if I look at that, so that's negative 4.9 bracket 0 squared plus 29.4 times 0 plus 2. Well, I just did that. I just told you that. The y value is 2. So I know that my y1 is 2. So we can put that in here. Whoops. I know that my y1 is 2. And I can do the same thing for my second coordinate. If I want to figure out what y2 is, well, I'm going to sub in x2 into my equation. So that becomes negative 4.9 bracket 1 squared plus 29.4 bracket 1 plus 2. And if I sub that into my equation, now what I'm going to do is I'm going to pause the video and just make sure and just do the other calculations so you don't have to sit through me doing these calculations. So negative 4.9 bracket 1 bracket plus 29.4 plus 2. So that's about 26.5. Now, it is a rate of change, so it is a slope. So this is going to be height. Well, I guess we can do this. This is going to be height is measured in meters per second. So it's going to be meters per second. Meters per second. And what we can do is we can put that value, that 26.5, 26.5. Oh, no, that's not. Sorry. That's not, because that's just a value. That's just my y coordinates. Okay? So now I know my y, I know my x1, my y1, my x2, my y2, and now I can determine my A rock, which is y2 minus y1 over x2 minus x1. Or another way to write this is to just write f of x2 minus f of x1 all over x2 minus x1. Oh. Right? And we know those values. We just calculated those values. So that's equal to 26.5 minus 2 over 1 minus 0, which is equal to 24.5 over 1, which is equal to 24.5 meters per second. That is our first A rock, or our very first average velocity. Okay, I'm going to pause this just to make sure that I do the calculations correctly, and then I will continue this part of the video. Okay, so now we're going to do, now we're going to figure out our next point. Okay, so with this next one, now we're looking between t equal to 1 and t equal to 2. So maybe that's these 2 points here. And what we're looking for is we're looking for the slope of this secant here. Now, what you'll notice just by looking at this is this secant is less steep than the one we just found the slope of. So our slope should be something less than 24.5, okay, for this to actually make sense. So we'll go through our calculations again. Now, my first point is going to be at time equal to 1, and we know that one, that's 1, and my y value when t is 1, my y value is 26.5. We just calculated that in the previous one. And my second coordinate is when t is 2, and for this we basically need to figure out what my y2 is. So again, this is my x1, y1, x2, y2. And we need to figure out what that value is. Okay, now how do we figure that out? Well, I sub 2 into my equation. So my y2 is equal to f of x2, which is equal to negative 4.9 bracket 2 squared plus 29.1, 29.4 bracket 2 plus 2. And what I get is I get a value of 41.2. So I can sub that in. This is 41.2. And now we can determine our A rock, our average rate of change between those 2 points. And again, all we're doing now is we're just finding the slope. Okay, we're just finding the slope between 2 points. So y2, 41.2 minus 26.5 all over 2 minus 1, which is equal to 14.7, and that's going to be in meters per second. Okay? That's all we're doing, right? Once you know your 2 points, once you know your y1, your x1, your y2, your x2, you just sub that in, right? And all this is like I said, y2 minus y1 over x2 minus x1. We're going to do the same thing for the last 2 points, okay? Now, my graph isn't very to scale here, as you can probably see, but let's say this is 3 here, right? So now we're finding our average rate of change, or our slope of this secant line, and you notice here that it continues to get less and less steep, okay? So let's figure this one out. Now my first point, my first coordinate is going to be, well, when t is 2, my y we just calculated is 41.2. And for my second coordinate, when t is 3, what is this coordinate? Well, we're going to calculate that. So again, I know my x1, I know my y1, I know my x2, I just need my y2. So we're going to calculate that. So that's going to be y2 equals f at x2. So I just sub x2 into my equation, which is negative 4.9 bracket 3 squared plus 29.4 bracket 3 plus 2, and that's equal to 46.1. Okay, we can put that into here. 46.1. And now we can calculate my AROC. My AROC, or my average rate of change, is going to be, and I'm going to write it this way this time, f of x2 minus f of x1. Let's make sure I didn't stop anything. Oh, we're still rocking, okay. All over x2 minus x1. Well, f of x2, we calculated that here. So that's 46.1 minus f of x1 is this value right here, my y coordinate. So minus 41.2, all divided by 3 minus 2. And when I calculate that, I get that's equal to 4.9, and that's meters per second. Okay, so we've calculated 3 average rates of change. Again, average rate of change is just the rate of change between 2 points in a non-linear graph. And I'm going to write that right here. Okay, let's do like a little star. Average rate of change is the slope between 2 points of a non-linear graph or function. That's all it is. Figure out what the 2 points are, calculate the slope, just like you did in previous years. It says, as time increases, what do you notice about the average rate of change? Now, again, for me, when I read average rate of change, I always read this as slope. As time increases, what do you notice about the average rate of change? Or, let me read the whole thing, and I'll read the whole thing both ways. As the time increases, what do you notice about the average rate of change in height during each 1 second interval? What does this mean? You can also read this as this. As the time increases, what do you notice about the slope in the height during each 1 second interval? What does this mean? Okay, well, what do we notice? It is decreasing over each 1 second interval. Period. What does this mean? This means that the ball is getting higher at a slower rate over time. Okay. We can look at this in terms of the graph, right? We looked at this kind of earlier. We saw that our graph was kind of a parabola, right? Which basically means, and you can look at the graph, as we go from left to right, right? Right here, it's pretty steep. It's getting less and less and less steep. So which means that it's not getting high as fast. And to a point where then it reaches its peak and it starts to decrease. And as it starts to decrease, it starts to decrease faster and faster and faster. Okay? And that's what average rate of change. That's the idea behind average rate of change. There are some questions from the textbook here. It does say to read some of the pages there, so you can absolutely because I think it goes through over some examples on those pages. It does, yeah. So you can read through some of those examples there, and then try out those questions there. Okay. Um, if you have any questions about the homework, please just send me an email, and I will reply as soon as possible. Okay. Thanks. Bye, and have a great day.